Okay, Richmond. Somebody let me know when we're online again.
Should I add the foreign keys?
Good. Okay. We have an admission here. I'm not sure any of us in Winston-Salem are qualified to turn on a computer. Guess what it was? Our communication equipment, our TVs, were plugged into a surge protector, and the surge protector was off. So there was nothing wrong with the cabling. We just didn't turn the switch on. So now that that's behind us, we've had our first small victory of the day. Let's take a close look, and I'm not going to get into the details of this database because that's really not why I'm showing it to you. You can see how many tables are there. You know, there's probably 119 tables. That is an application that runs this entire business. So they do everything from order placement, vendor orders, inventory. They do shipments, everything for 119 tables. So that's a medium-sized database. Okay, 119 tables that you can probably guess it's medium size. And there's more tables in here that are needed. So like I said, this client has actually said, you know, it's getting kind of crusty. This is a really old system. We want a new rewrite. We want to feel good about ourselves and have a new flashy front end. We want to integrate our website. They want to do some new things. And I put them off for like a year and a half. I put them off for a year and a half because, number one, they're kind of like friends, but also paying friends, which are, you know, the good kind. But they're also, I didn't have the time. We didn't have the resources. So we have other clients that are more demanding and not friends. I don't know if you all have ever been waiters or waitresses. I've been a waiter before. And one of the bad things, this is the truth about life, unfortunately, if you have nice people at a table and you have real jerks at another table, it's human nature. It's like, I'll take care of the nice people, but the jerks are going to get, unfortunately, more attention. That's just human nature. It's like, yeah, the nice people are not going to bother me. They're not going to yell at me. They're going to be nice. They're going to be all right. The jerks are the ones that you got to deal with. So, unfortunately, it's like that in consulting, too. I wish it weren't like that. The nice people always get screwed that way, but, you know, that's life. So, here. That's not the moral of the story today, by the way. So I'm pointing out this database table. Getting back to the thread, though, the reason I'm showing this to you is because just because you've learned to expect primary keys and foreign keys to be named a certain way, I used to think it was cool to name things this way. Can you look at this table and tell me what's going on?
It's a really long name for a primary key.
Yeah. It's, I could name it PK underscore whatever. PK underscore used to be my standard naming convention that I liked to say primary key underscore whatever table name. But that required me to write underscores all the time. And it didn't really play nice with any of the middleware tiers. So I stopped doing that like 12 years ago. But why is it still like this? It's because database stuff doesn't change. Because once you have a database and you write code against that database, the code needs to know the names of your columns. So there's a domino effect. And sometimes the names of your columns will leak into even the user interface in your JSON, your JavaScript. So once you decide your database, it doesn't often change. Why? Because you could change it, but then you're going to spend days reworking a bunch of stuff. And at the end of that, what are you going to have? The same thing you had before you started. Because all you did was change the names. If you're lucky. If you're not lucky, you introduced a whole bunch of bugs. And then the client says, you're trying to charge me for 3 days of work, and what did I get for it? A bunch of bugs? It doesn't happen in the real world, even in the corporate environment. If it works, don't rock the boat. So where is your first chance, and only chance sometimes, to get your database stuff right the way you want it? When you create it. Which is why stop, think about it, do it right, change it before you start writing code against it. Because after you start writing code and you write user interface against that code, then you've got a domino effect. And in the real world, things don't change because there's no justification. So here, the reason this is still named weird is because nobody wanted to pay me to go fix my naming convention. And it works just fine. It just means I've got to type a little bit more when I do my joins. What does that mean? Foreign key. So it's readable. You know what I mean. It's just a little bit weird. you're going to see different naming conventions everywhere. That's really the point. There's lots of things here. Things that I would probably do very differently now. I know I would do it very differently. And if you come work with Sightsource, I'm going to expose, here's how ugly that database really is, and here are the things that, please go fix it for me. And I will share all the nasty details, all the skeletons in the closet with this application. It's written in C#, by the way. So C# you're about to learn. And you would be rewriting it in either Angular, JavaScript, TypeScript, or C#. The back end will remain SQL Server, but you can rebuild the database. So that would be fun. You know, from application developer, that feels like, oh, that's like a monkey off my back. Once this happens, that's like, okay, I don't have to go deal with that legacy application anymore. Even though it's my own code, I'm not proud of it. So that's a real database. Let's talk about your example there, your database. Who wants to share ideas? I don't want to see your entire schema, because one of the beautiful things about databases is everybody gets their own creativity, and you can put whatever you want in your database. And this was so large. Somebody asked, where do I even start? You really start, and I really do this. I still get a piece of paper out, and I got a tablet, and I thought, you know, it's 2017, 2018. I should probably stop using paper. Maybe I should use a tablet and save some trees. I still use paper. You know, I've got a tablet. I just don't use it for this. I got one of the stylus things, and you can, I still don't use it. I like paper. So I get a piece of paper out, just like you just did. And whenever I have a new client estimate, I'll go off with a piece of paper, and I'll draw little boxes on it, and I'll draw the lines. And then once I'm happy with it, I will write the estimate, like a formal priced estimate based on hours. And from the database, I can tell, based on experience, the application is going to be about this big. Can you all tell, just doing the database, how do I know how big the application is going to be? Because for every table, there is a domino effect. If you start seeing the matrix, the pattern here, if you can build a table, you're probably going to have a class. You don't know what a class is. Think of it an object in your middle tier. And then you're probably going to have a screen, one or more screens in your user interface. So just from having, I've covered all the bases with my database design, I can extrapolate. This is probably how big the application is. And I can imagine what it's going to look like. So just from building the database, with not even all the fields in the tables, I can go through and estimate. And I can put hours together, multiply that by whatever rate, write up a really nice formal estimate with logo, and I'll send it off. And I won't do anything with it. I'll forget it ever happened until that customer comes back and says, you know, that's great, let's move forward. At that point, I'll pick up the piece of paper, and I'll go build it. I'll go write DDL scripts, and I'll add the columns. That's where you start thinking again. That's stage 2 of this little puzzle. Step 1 is build the relationships. Step 2 is, within that table, what are really the information that they want to collect? That's where you have to start thinking about data types. You have to start adding columns, and it'll take, a few hours. So this half-hour thing for a database of this size, no. Even professionals don't take half an hour to build a database of that size. An estimate that I would give a customer, if they said, we want to build a festival site for Woodstock 2019, I'd ask 100 questions of them. I would try to get all the information. And then I would go away and I would say, okay, to build the database is probably going to be 6, 7, 8 hours. And what am I doing for those 6, 7, 8 hours? I'm with my piece of paper, I'm with my DDL script, and I'm doing that. So exactly what you're doing, that's real time that you can bill a client for, because you're building something that they don't know how to do. And that's step 1. Once you have your database, you can model your classes after your tables. You can build your user interface based on your class relationships. So it all starts with the database. Enough of that. Let's get back into any questions before we move on.
So when you're mapping this out, one thing that our group found, and me specifically, is a problem for me, is mapping it out becomes very difficult when I can't imagine the column names. So does that process always have to be like tables first and then column names?
So Scott's asking, in case Richmond couldn't hear, his thing is, sometimes it's difficult to imagine the proper relationships if you can't see the column names, or you haven't thought of the column names that would go in that table first. And my answer to that is, do it however it makes sense to you. If you want to add, think of a couple column names in that table, you're going to have to do it eventually anyway. Yeah, go ahead and throw a couple columns there if it makes more sense to you.
Sure. Okay.
Yeah, there's no right or wrong way. It's whatever makes sense, whatever helps you be productive. I don't want to go over everybody's database design. The point of that exercise was to go through it and to brainstorm ideas and put tables together and the relationships. I do want to raise, anybody had a question or something they got stuck on, or something they put down on paper and it's like, that's probably wrong. I don't feel good about that.
Well, just in general, your approach. Like, because for me, I feel like I need like a starting off point, which is kind of like a main table. You know what I'm saying? And like I was kind of talking about that with my group and with Kelly. And like I don't think everybody agreed with me, but like so I don't know. How do you go about that?
So I think that's Chris back there saying, I'm not sure I'm on board with your approach, and it's perfectly fine if you think a different way. Not everybody thinks like I do. He's saying, I have a hard time without having like an anchor table, like a first table, this is really what I'm building. And then from there, you kind of build more tables around it. That's perfectly all right. There's no right or wrong. If you want to start in this, did you come up with an anchor table that made sense to you?
I mean, the closest I came up with, or we came up with, was like just a venue. So that, you know, like the kind of the bands would shoot off of that, and then like the ticket holder would shoot off of that.
So to repeat for Richmond, he said venue was kind of the table that he came upon that really made sense to start with. And I'm saying there's no right or wrong because I know that if you cover all the bases, you're eventually going to have to cover all the tables that you need to store data. So it doesn't really matter where you start. And really, I don't care where I start either. It may seem like that, but I just, okay, where do I start? Band, okay. Because in a relational database, you remember how they're all kind of connected most of the time? Wherever I start, I'm going to thread out, I'm going to spider out to eventually cover most of it. And then I'll look at, like, what am I missing? And then I'll add another couple tables that may not be related to the rest of them. So the answer to that is start wherever it makes sense to you and go from there. And the only thing that matters is after you brainstorm, it's like, okay, let me look at my picture. What am I missing? Add another couple tables. That's all you do. It doesn't matter where you start. Any other people maybe in Richmond that, okay, Kirsty?
We had it where, and you saw it, we had the customers at a different place than the venue and the bands and everything. We had a basically different databases, technically, right? For both of those? What would it be?
Technically, there's a database context and it's a group of tables. So if you have 10 tables up here that are related, and you have another 5 or 10 tables down here that are related, but they're all in one database context, it's still the same database, technically. Okay. Now, could you have made a separate database? Yes. There's nothing against that.
But
each database, there are some things that I haven't, based on time, had the ability to impart knowledge-wise, and that's security. So security within SQL Server and a lot of other database platforms is handled at the database level. So if you have 2 different databases, you're going to have to apply security on both of them identically. So it's kind of an overhead. If it's going to have the same security model, usually you throw it into one database. Even if they're not related directly, you do the security once, and it covers all the tables inside of it.
I see.
So, but you raise a very good point. Just because you have 50 tables doesn't mean all 50 of those tables have to be related. And I remember your example. In this, y'all in Richmond probably had the same situation. You kind of are dealing with 2 or 3 different business problems. One is, I'm selling tickets to people coming to the show. You have a completely separate group of business problems having to do with organizing the show. So some people got stuck on, a ticket holder should never be able to see like the security guard's home phone number. It's still in the same database. They're in different tables. But the list of security guards or security personnel, whatever you call that, if you model that table, there is no direct relationship or even a relationship to a ticket holder. How do you control that? That's application security. Through your application, you don't give the ticket holder access to see security guard personal information. That's an application security. You could also tie it down at the database level. But it exists in the same database, often. It doesn't have to, but it often does. Just because tables exist in the same database doesn't mean you have to draw lines between them. Don't force yourself to do that.
So there's a way the middle tier calls to those separate branches.
We know that, yes. So Kirsty is saying that The middle tier can decide then about which tables it pulls. We know how to do that. And that's a perfect segue into what I'm going to do next. We're going to talk about SQL again. So a SQL select statement is how you join tables together. So if you choose not to join those tables because there's no relationship, they don't get it back. The middle tier only sees what you expose through select statements. This is where it all comes together. You design your database, you build your relationships, you build your DDL. Now DDL is over, data definition language. Now we're jumping into DML, data manipulation language, which is select, insert, update, delete. You're playing with the data in those structures. So getting back to selects, which is probably the most important skill you're going to walk away with in all of this database discussion. You may go on, and as much as it pains me to say this, you may never be a database developer. But no matter what you do, if you are a developer, you will write SQL. Okay? So database developers and designers, they need to know the DDL, how to create tables and modify things. Everybody, even if you're not going to be a developer, you better know SQL because it is as commonly spoken as nearly English, because it's not just English people that speak it. If you're in Japan, I bet you they use SQL. So let's get back to, I sent out a little thing this morning that I'm not sure everybody saw. It was in code, and I said, go ahead and run this script. Can anybody tell me what this script does? And I haven't run it on this computer. I did it on another computer this morning.
Creates a database, creates a table. What's that whole table?
It creates a table, or creates a database called this.
And it says data.
It creates a database, and it creates tables, and it puts data in those tables, all with one script. Think about the difference between doing that and using the designer. And this is important because this afternoon you're going to go and write your own database, and you're going to deploy it to the cloud. Think about the complexity. What are the mechanics? You build it, you're happy, you use the designer locally. How do you get it to another computer? There are two ways that you know of at this point. Tell me the two ways.
Scripting.
You can script it like this, and you can, by the way, if you actually build the database, let me go ahead and run this. Notice there is no database over here named SQL test. I'm just going to run it. And it went ahead and built it, my entire database, and the tables, and it has data. So there. That's one way. What's another way?
Backing it up.
You can back up a database and restore it. Those are the two ways that are commonly used to get data from here to there. So later on, remember that because you're going to need to do it, probably with a script. So let's take a look at writing a query or two against this database. I purposely made this very straightforward. That is the entire schema. Question?
I have just a general question. I don't know if it's obvious or not, but so when we're running this on the local server, it's our computer, right?
Yep.
But if
So the question is, when we run this, are we running that on our local computer? The answer is yes.
but we don't want to store a database on a local computer, right? We want to store it on a cloud.
And Anna's saying, that's silly. Why are we doing it on a local computer? We can't share it with anybody. Because as a developer, you want a copy of your database locally so that you can change it, play with it, and test it. And when you're happy with it, you put it over there for everybody else to see. Because I don't want everybody else seeing my mistakes as I'm developing.
Okay, so this is when you are creating the database or when you have to change it for some reason. You have it on your local server, but then well, how do you...
So Anna's saying, she's talking through, like, so this is for developers only? Right. Users would not normally have a local copy of the database. And then, I'm sorry to interrupt you, I'm trying to keep them up.
Oh, that's okay. And then you deploy it? Is that what you call it when you put it on the cloud?
Publish it, yeah.
Yeah, publish it, deploy it. So what's the term for taking it from here and putting it over there? Publish it, deploy it. And you may think, I'm jumping ahead a little bit, but there is the complexity. Say you have a real mature application. Say this application has been in existence for 18 years. If I make a change to my database here, I've got to make that same change over there for them to see. But I'm going to make the change here and test my code before I give it to them. So how do you keep that in sync is probably your next question. There's something called migrations. And that, I'm sure Derek is going to go over that. And if not, I'll jump in, or Harper will jump in. Harper is much better at that, actually. It's the concept of a DDL script, a data definition language script, can say, here is your initial database. It creates everything. Oh, I'm going to add a column to this table. There's that little bit of script. So you're incrementally making changes to your database. What people do in the real world as professional developers is you have a script, and then as you make changes to your code, you also make changes to the database. It's common. So what you do is you write a little DDL script, or you say, SQL Server Management Studio, execute me the change script. You save that, and you check it in with your code. And then there's something called migrations that says, I'm going to run the change scripts in order. So at the end of that, what they see as the users, when you deploy your code to production, you also deploy your database changes to production in lockstep, so that the code goes with the version of the database. You have to be careful because they have real data. Your development database doesn't. So that's where you have to think a little bit about, if I drop a column and recreate it, I just lost all their data in that column. So you don't want to do that. So you just have to be a little bit careful about thinking, when I put it on the user's production server, what are the considerations? But that's a whole other discussion that full stack developers need to think of after you have a middle tier.
Is that similar to how Git makes changes to, or how you can use Git to change?
So the follow-up question is it like Git where it keeps track of your changes, your commits? And it's exactly like that. Migrations is like Git's log of commits for the database, and it can roll forward or roll backward. So, any other questions before we move on? Good. So let's start from scratch with SQL. Y'all tell me. This is like your review day, and I'm trying to go through everything again. Question?
Can you enter the password for your laptop back here?
It's
It's a lock screen.
yeah. Hold on just a second, Richard.
I tried in Power, but
Correct password.
Yeah, it's messed up.
Pepper, 1, 2, 3, 4.
That's so many characters. I'm reading all these numbers. That's what you
You have to, though.
No, I've seen that. There's literally a paper for it. It's wrong as all.
So, let's start with a very simple select statement. I taught you yesterday, I think, yeah, it's still up here on the board. We've got, I don't know if you can see that, Richmond. This is the order of the statements in a standard select statement. Select, column list, from, table. That's the very basic. You need to have that. Very basic. So let's do that against customer. So this is your schema. Any questions about the schema before we go on?
When you're creating a new table, do you need to finish it with Go? What does the Go specifically do?
Go is, here's another thing about technical terminology. SQL Server uses a dialect of SQL called Transact SQL. People call it T-SQL. So that's SQL Server's version of SQL. In Transact SQL, Go says run a batch. Here's a list of SQL statements. I want you to go execute that entire batch right now. Go do it now. In other languages, notice down here I have a semicolon. Semicolon is the normal standard SQL syntax to say, I'm done, execute that statement. SQL Server and Transact SQL consider the semicolons optional. It's smart enough to say, oh, you're going on to the next statement. I'll infer the semicolon. As we see in MySQL and PostgreSQL later on today, this morning, those are not optional in other platforms. In Oracle, PostgreSQL, in other dialects, you need to have the semicolon. The other dialects do not have the Go keyword. So that's specific to Transact SQL. Getting back to your question, why do I have Go? Go says, I want to create my structure before I start inserting data into that structure. If I left off the Go, that table may not exist before I try to insert data into it, and it may fail.
Gotcha.
So Go says, make sure that's done before I start trying to talk about it.
Okay.
Normally, you don't have to do Go. You just do semicolon. And I think a semicolon would actually work there too. So, other questions about the schema or the data that we're looking at? We just have 3 tables here, and that's all 3 of them. And we have just, I think, 4 customers. And we have, what, 4 or 5 orders, 8 orders, a few order lines. So it's a very simple customer, orders, order line. One to many, one to many. The purpose of making this simple, and we've got some very simple data in here. That's it. That's all the data. I wanted to go over some of the things that I felt like you all were stumbling on yesterday. Let's start with a very simple, give me the first and last name of all my customers. Okay? Let's start at the very beginning. Somebody quote me the SQL. I've got a table named customer. Richmond yelled out at Harper, we need to be interactive. You need to get this. So how do you say, give me the first and last name for my customer table?
Select. First name, last name.
Space, comma.
Comma, space.
Make sure you have the right thing
Customer.
Is that it? That's it. See it? It's very straightforward. That's it. You're exactly right, Chris. So I'm going to, now, from now on, I'm going to start using the semicolon to say that's the end of my SQL statement. Because PostgreSQL, MySQL, Oracle, they all require it. I ran it by pressing F5. Yep. Actually, I was thinking this morning, who would I like to be at a dinner party with? And if I had these 4 people at a dinner party, I'd just sit back and listen. So you got first name, last name from customer. Now, what if we want to get rid of, we want to keep Kim out. You know, we don't want to have Kim Jong-un out. How do we make it so that we get rid of his record? He's not invited anymore.
Well, we should start out with the select statement to make sure we don't accidentally delete something that we don't need to.
Oh, we don't want to delete anything. I just want to exclude it from the query results.
Oh.
Yeah, I don't want to delete Kim Jong-un. Yeah, see, he didn't do that. You know, he hasn't done anything nuclear yet, so you know, we'll give him the benefit of the doubt.
Could you put the same statement but add their first and last name?
Where clause?
Not. Give me on.
So talk me through it. What field are we talking about?
Not
So
number
where?
2.
And then we would want to do ID.
Hmm.
Or we could just do last name, I guess.
Yeah.
Talk me through it. This is the thing. Rubber hits the road. Soon, you're going to be an application developer. You've got to write your own SQL against your own database. So you need to get good at this.
So you can do does not equal 2 different ways.
Yeah, you could say it like that,
Coming in.
or you could say it like that. It's the same thing. Not equal to what?
And
String
then
is last name.
And then you
Single
just
quote.
use a 2, can't
And then last name. Oh, no, it's not. This would actually be his name. Young sorry.
Couldn't you just use the ID though of his name?
Not always gonna know the ID.
So the question is, couldn't you just use an ID?
Okay, it's not an ID, I see that.
Yeah, you could use an ID if you knew it.
If you had one.
Okay, so Anna's saying, yeah, I want to use the ID. I want to use the primary key. And Derek would pat you on the back right now. It's like, yes, use the ID. And I'm going to write that slightly different. Same thing. Which is more efficient, just as an aside?
ID.
ID.
Someone else may have the same last name.
Exactly right. Yasmin's pointing out, you know, we only have 4 people in here, but, you know, those crazy Koreans probably have like 50 Young-uns. So if you said you don't want to invite Kim Jong-un, you're excluding that entire clan, and it's probably not what we want to do. So ID is going to be more specific, which is usually better. So we got a where clause. Where clauses for that? Filtering. Question.
So isn't his last name Kim? His first name
I think it's
Kim?
Youngjun Kim, yeah?
Yeah.
Yeah, I don't care about him enough to do it properly. But yeah, you're probably right. So I'm going to leave that there, and I'm going to post this code in Slack after we're done. So that's another way to say, except him. Now, I want to see, show me all of the orders related to these three people, in addition to their names.
Okay, so now we want to do a join.
Okay? Now, somebody said we're going to do a join. You probably is like, okay, here we go again. Don't get lost here. Step by step. We're going to do a join between customer and orders. Why are we going to do that? Because customer has a primary key called ID. Orders has a foreign key called customer ID. So by looking at that, that's probably how they connect. Are we going to do an inner, left, right, cross, full outer? What type of join are we going to do? Inner join. Inner join means it's got to match. In other words, in English, we only want to show the orders where there is a customer in our list. It's got to match. So how do we say it? I'm not going to write your SQL for you today.
Inner join, and then customer, or not, sorry, orders. I meant orders.
Any idea about why I called it orders, plural, instead of order?
Because it's what your column is?
Because
Look at all the other two are singular, order line and customer.
Are you going to have more than one order?
You're gonna have more than one customer though too, so.
You have it's named orders, right?
What else do you know in SQL that's called?
Order is a
keyword. Order by. So if I said order, I would have to put it in square brackets all the time.
Right.
Oh, okay.
So I'm circumventing using a keyword.
I have a question about the square brackets. Sometimes when you concatenate and then create an alias, so if you're doing like first name plus last name as full name.
Like this down here.
Yep. So sometimes we see as the alias in square brackets. Does that denote anything specific?
Okay, so the question is, when you have square brackets, why do people use them? So if I want to have the full name up here, so I'm going to say first name. How do you concatenate, by the way, in Transact SQL? Simply? Plus, just like JavaScript.
You can also use the concat.
You can also say concat, which is going to be cross-platform, so it's slightly better because you can transport your SQL easily. So Scott's question was, he's seen that before. Why are we using square brackets? We're using square brackets to be explicit. We don't need them here because there's nothing special about full name. But if I put a space in there, you have to do square brackets to let it know that's the whole thing. Otherwise, if you didn't put square brackets, what's it going to do? It's going to like, okay, that's a syntax error because it's expecting one name there and it's got a space and it's like, what are you talking? It's thinking that you're trying to go onto the from clause. It's not going to be able to be parsed. Why would you normally do that? Because the users insist on having in their report, in your select statement, I want to have % change over last year. That's going to be the name of the column, and they want to see that. Or your application developer says, I want it to be called this. Okay, you can name it whatever you want, just put it in square brackets.
Can we use that for getting around those keywords as well, right?
Yes, as a matter of fact, if I weren't a lazy programmer and I kept with my own paradigm, I could say order, and I just put it in square brackets. That would work too. But I don't like to type if I can avoid it. It makes it cleaner just to look at. That's why I do that. Now, one thing we haven't done here, so we've got, let's run this. Let's make sure it's still working. It's not going to work because we haven't finished our join. We got sidetracked. Help me with the join. So
ID for customer table.
You have to let it know which table it's talking about first, though. And so it would be customer.id, so it knows which ID.
Scott's saying, you know, ID sounds good. That's right, but which ID? We've got an ID on the orders table, and we've got an ID on the customer table. It doesn't know which one. Let's try it without, and let's see if it'll figure it out. Let's just write it without the prefixes, all that. You know, let's see if we can do it and get away with it.
It would be equals customer ID, because that's the foreign key for it.
So we're saying the ID, what we mean is the ID on the customers table and the customer ID column on the orders table. That's how it matches.
Right.
And now we're saying, oh, we have two columns up here and we've got an ID. Which one is it talking about? Well, let's, you know, stop complaining, SQL. Just do it. Yeah, I need a pep talk for SQL Server. Just do it. So, ambiguous column name ID. It tells you exactly what the problem is. It says, you didn't tell me where that belongs. Which table are you talking about, dude? Okay. So, let's do it longhand. I've done aliases, and Derek did aliases from the first SQL statement he wrote. And a lot of you don't understand why we're doing that. Let me show you what it looks like if we don't do aliases. Let's do this full longhand. Help me out here. How do we do that?
Customer ID.
We have to tell it which table it belongs to.
Orders dot customer ID.
And down here we have to say what?
Customers. Or customer dot ID.
And that works just fine. Now,
So they're funding that.
what about these things up here?
It still doesn't know
Those
where
all
to get
have to
those.
be identified as.
SQL is smart. It will let you, don't do this, but this will work. Can anybody tell me why it worked?
Because first name and last name are only in one table.
Because first and last name only exist in one of the tables referenced. So SQL says, can I find it? Is it unique? Yeah, you're good. I'm going to let you be lazy. Don't do that, okay? The right way to write this, because other developers are not going to be as smart as the SQL parser. They're going to say, like, where is that? Which table are you talking about? So it's better to say customer.firstname, customer.lastname, customer.firstname, and so on. Now, we have like 3 columns. You see how verbose and hard to look at that is? Let's make that pretty and easier to parse as humans. How do we do that? Let's use table aliases. Tell me how to do that.
You could
C.
just do a space and then whatever you want your alias to be.
Why do we do it here? Why don't we do it up here when we first talk about first name?
Because you give the alias when you tell it where it's coming from.
Okay, so this is a very important point, and I think a lot of people have been stumbling on where do I do my alias? I'm talking about my alias before I define it. You always declare your alias in the first time you reference the table in your from clause. That's where you give it the nickname. That's where it comes from. So that's why you come here first, and you go back, and then you reuse it elsewhere. So let's give it the alias for orders. Let's follow the process as you would write the query. O. And now, that's all I've done. That little place, I've nicknamed both my tables. I'm done with nicknaming. Now all I have to do is go use that nickname to talk about the fields. So let's get rid of customer everywhere and replace it with C. Let's get rid of orders and replace it with O. And you're going to see it's like, oh, that's why I use aliases, because I don't like to type. And it's easier to look at. If you've got 50 columns, you don't want to see that table name spelled out 50 times. So now, we've gone through a very simple inner join. We've gone through table aliases. What is this thing up here, the as?
You're renaming the last name and first name columns into just one name, so you can combine them together.
Anna has it exactly right. What I'm doing is I'm calculating a column for the output, and I'm giving it a name. You're saying, you know, that one doesn't even have a name because I'm calculating it. Let's give it a name of full name. So if you look down here, that's the name of that column.
So
Do I need the as?
an alias as well, right?
That's a column alias. That's exactly right. Chris is saying that's an alias, right? It's like, yes, that is a column alias. These are called table aliases because we're nicknaming a table. This we're nicknaming a column. As is optional up here also. This will work just fine. I don't like doing that because it's harder to read for me. when I'm looking at the columns in the output, I want to like, oh, I'm explicitly naming it that. You can have your own style. I'm showing you all the options. So we've got 3 columns in our output. We've got a join. You know, this doesn't make a whole lot of sense, though. What's going on in our results here? Nicolas Maduro is throwing, several, Ricky Bobby is showing up. What's going on here? Can you tell me why that's happening? You could do a distinct. Yeah, you could get rid of those duplicates, but there's a reason we did the join. Why do you think we did the join?
We have information from both tables.
We wanted to get information from both the tables. What are the 2 tables again? Customer and orders. Are we showing any of the order information? No. So the table's joined, but we're not showing any of the results from one of the tables we're joining. Let's take a peek at what's in the orders table. So how do we add columns to our output?
Comma, and then whatever column you want. So you actually, you could just do all, little star.
You could just say, okay, that's one way. Let's see how that looks. It's like, oh, now I see why it's duplicated. It's not really duplicate. Those are the order IDs. Nicolas Maduro had 3 orders, 2, 3, and 5. That's why he's there 3 times. And they're placed on 3 different date times. Now, there is another way to say this. I would argue this is not a good way to do it. You can say that. Remember the star where he says, give me everything from the whole query? You can say star just for one of your tables. So this will give me all of the fields from orders. That's just another way to say, in this case, we've got 2 columns instead of 3 if we spell it out. I'm going to leave there as a comment. So let's get back to this. We did a join so that we can look at the orders for these customers. Now, there's one more table in there, and that's the order lines. I want to see how much did Nicolas Maduro spend for each one of these orders. I don't want to see the details. I don't want to see whatever he decided to buy. Where is that stuff? We've only got 3 tables here, guys. Come on.
It's an order line.
Order line. How is that related to the other ones? Now, this is a critical point because we're going from 2 tables, which you may feel like, yeah, I know that, to 3. 2 to 3 is the breaking point where a lot of people don't cross that hill. You need to understand what's going on here. I'm joining customers to orders. After that, that's done. Imagine these results. Now we're going to join these results to the next thing. That's the way to think about this. So we're going to join these results to our order line. How do we say that? What's the table we're joining?
Orders.
Are we going to give it an alias?
Yeah.
Yeah.
Well, on, order, O.
ID, you think? I could type this out, but I'm doing this, y'all gotta help me.
Equals, and then OL, and then you have to find the foreign key, which would be order ID, and that would match.
Okay.
So stop for a second.
Question.
Yeah, because when you do the inner join then of the secondary table, it automatically goes off of, it just reads back to the previous one of orders, and so it knows to inner join with orders and order line.
So the question is, when you do this, when you add line 6, and we're adding order line in, does it know to automatically join back to the previous stuff? There's nothing automatic about it. What we're doing is we're saying we have the ability. This down here is the results of the join of customer to orders. Because we've joined those 2 tables, all of these are options available to use. So this is, I could join to any one of these columns. It doesn't have to be joined to orders. I could join it to customer if that's really what was appropriate.
Oh, I see. So you're doing a join between order line and information off of the orders table.
Yes.
I mean,
So
off
that-
of the results of your previous join.
So we're not, yeah, when you join a third or fourth or subsequent tables, that third is joining to the results of the join of the first two tables.
Got it.
If you're joining a fourth table, you're joining to the results of the first three.
So you're always doing a join to the previous, the results of the previous.
So we're always joining to the results of the previous joins that came before me, as it's written.
Be important.
It's very, very important. That's how you read the select statement. Question.
So is that, so you're doing the inner joins that way because the columns, or you have the ID of the customer in the customer table, and then you have the ID of the orders in the order table, which is also connected to the customers table, and then you have the order line.
I follow what you're saying. So Anna's walking through, did you write it that way because you have a customer ID that relates to it, orders.customer ID? And the answer is yes. Could I have written it backwards? Could I have written order line to orders, join to customer? Yeah. All that matters is you daisy chain them together.
So what happens if you skipped orders and you just wanted to know how much Ricky Bobby bought? Like, how much you...
Very good question. Anna's saying, well, I really don't feel like joining orders because we don't really care about, the detail of the order number. I just want to know how much Ricky Bobby bought. How do you get to, let's look at our database schema. Where is the amount that Ricky Bobby purchased? Where is the price field? So we have customer, order line, and order. It's on order line. So if we have a customer, which is Ricky Bobby, and we want to know how much did he spend, the only way to get that is through the order table, because you have to connect the order table to the order line to get to the price fields. That's why you do the joins. And it's common in relational database design. You have to go through another table. Even if you don't care about the fields on that table, you're using the foreign key and primary key relationship to get to the tables you want. So the answer is there's no way to join order line to customer directly. You have to go through order.
Because it has to have the foreign key.
Specifically.
Do you only join it on the foreign keys?
No, so she's trying to find a way around this. She's thinking, well, can I join by something other than the foreign keys? Yeah, knock yourself out. You can join on any columns you want. Trying to find one that will actually give you the data you want is going to be difficult. But if you know that, like that date, if I want to say that date, join it to that date, yeah, you can do that. It's all just information. You got to know what information matches. There's nothing special about primary foreign keys, really. SQL just cares that this matches that. So, 3-table join. Richmond, I haven't checked on you. Let's see how you all doing over there. Ah, okay. Harper has strong telepathy today. So we've got select, from, join. We've got a 3-table join. We've got a where clause. Can I take this where clause out? Would that still work? Can you have a join without a where? Of course you can. Yeah. You can take the where clause out, but we don't want to invite Kim Jong-un or Jong-un Kim, whatever his name is. So we're going to do that. And now we've joined to order line. And now we've got crazy results again. Why do we have crazy results? Why do we have what looks like duplicates?
Because it's taking information from the orders table, from order line.
Because we joined to order line. And it looks like, I bet you there are, for order ID of 3, I bet you there are 3 order lines on order ID of 3. But we're not showing any of the information from our order line table. So the results don't make logical sense to look at. So how do we show some order line information? Anna wanted to know how much did Ricky Bobby spend. We're going to write that query in a minute. But before, let's just say, order line dot show me the quantity, show me the unit price, and show me the extended price. So I'm going to run that query again. So now it's like, okay, let's go through and read this. Ricky Bobby has order ID of 1, There are 2 line items. Actually, we probably want to see what is the line item ID. We need to see a unique identifier so it makes kind of sense to look at. So this is, okay. Oh, by the way, why am I getting 5, 5, 5, 5, 5, and it's jumping by 5s?
Your seed plus 5, 5, 5, 5, 5, your increment is 5.
Exactly. For those of you who looked at my DDL script, look what I did in here. Normally you see identity 1, 1. I said identity start at that number. In every increment, I want to add 5 to it, not just 1. Is there a reason to do that? Most of the time, no. But strangely enough, people have this, I think it's something to do with how good they feel about themselves. Their self-esteem is like, I'm order number 5,372. I'm not order number 3. They feel kind of bad. It's like, I only have order number 3. So it's okay, give them a big number. It costs you nothing. So that's all I did. It's like, okay, your order number, line ID is 55560. That's all it does. Do you want to do that in the real world? With a seed? Seed is fine. With the increment? No. Why might not I want to do a 5 of an increment?
You're going to use up a lot of numbers really quickly.
I'm burning a bunch of numbers. And I want this table to last as long as possible before I have to touch it again. So I want to add 1 at a time, not 5 at a time. So that's unusual, but I wanted to show you that it's possible. So we got order line IDs, so now we can read this. So we got Ricky Bobby has order ID of, now that ID, it doesn't make a whole lot of sense. How do we give that a better name? You know a column alias, how do you say column alias?
As
What is this really?
customer ID? Or actually,
It's order ID. So O.ID is order ID. So, okay. So now we've got order ID. So now that's easier to read. So you've got first name, last name, full name, order ID. This is the place stat there. You see how that's different? That's why we have 2 rows, the first 2. Quantity 3 and 1. Now, look at what we did here. Unit price of 250 times 3, 750. This is a new advanced concept that I'm not going to spend a lot of time on, but I wanted to show it to you. Look at the definition of that column. That is an automatically calculated persisted, which means store the result on disk like a real column. But it's based on some logic. It's a calculated column that I've stored. Persisted makes it super fast. What's the difference between me doing this and just doing this in the SQL statement? The difference is, if I have it on the table like this, when somebody does an insert, update, or delete, not a delete because the record's going to be gone, but an insert or an update, its SQL Server is going to recalculate the value of this and store it, just like somebody typed it in. That makes it really, really fast when you select it. If I select extended price, I could easily say select quantity times unit price and do that in all my select statements. Or I could just do that in the table as a computed persisted column like this, and I can just treat it like a real column. If you don't understand or don't, that bothers you, forget I ever said it. Rewind 5 minutes, let's proceed with select. I'm showing you all the little features as we're going now. So we've got a 3-table join. We understand order line ID, quantity, unit price. We've got that extended price, which we know is computed persisted column, but it could have just as easily been unit price times quantity as extended price. Let's see what I really intended to cover today.
You said you wanted to see Bobby's only, right?
Yeah, before we do the rest of this stuff, somebody said they want to know how much Ricky Bobby spent. How do we answer that question? That's a real world question.
you probably get the sum of extended price and Bobby.
So this is exactly how you can start writing a query. Like, you know what you want, start writing it out. So select sum of what? What are we summing? What's the field name?
It's first name, last name? What? Oh, no, it's the,
Imagine your results. So you want to see the first name, last name.
yeah.
So what table does first name, last name belong to? Customer. So we're probably going to have an alias in a minute that's C, customer first name. Let's do the concatenation a different way, cross-platform. Okay, so we got the first name, last name. What else do we need? What do you want to see in your results? You got to imagine, what is the output going to look like? So we're going to have extended price. Where is that? Which table does extended price belong to? We'll probably give it an alias in a second about OL. Extended price. Let's do it one step at a time. We'll come back and group it in a minute. Let's not worry about the grouping just yet. That's a good way to do it. It's like if you're not getting grouping, if you don't understand aggregate functions just yet, write the query first and then go group it. It'll help you understand what you're doing. So we've got the full name and we've got the extended price. We're probably going to have to do something with that extended price, but let's do the joins. We're going to have to do joins again, right? As a matter of fact, it's going to be these same three joins. It's going to be customer. In order to get to the order line extended price, we have to go through orders. Because there's a primary key. Let's think about it. Anna's like, no, you don't. There's got to be a better way. It's like, okay. Let's start at customer ID. And we got Ricky Bobby here. And we really want extended price. But there's no column here that's going to relate directly to a customer. What we do have is a foreign key that relates to an order. If we go to orders, there's your customer. That's why we have to do a third. We have to join that inner table, just so we can trace it all the way through. So that's what we're doing here. Customer to order line. So we've got everything. Do you care about filtering? Like, I only care what Ricky Bobby spent in the past month or something like that? Or no? Just everything. So let's go ahead and run it. Uh-oh. Yeah, it's not, it doesn't have Harper's telepathy, apparently. We wanted Ricky Bobby. How do you say just Ricky Bobby?
It has to be
Where? Where is how we filter. Okay. Anna really wants to use customer ID. Derek would once again pat you on the back. So what is the customer ID for Ricky Bobby? How do we find that out? Here's how you do little diagnostic queries. Customer, you know, if you don't want to have, if you have 5 million rows in the table, that's going to take a while. So it's often to say, give me the top 5 from customer, where last name equal Bobby. Is it I? Bobby like that, probably. Okay. So that little query gives you the information because she wanted to use the ID, the primary key. It's like, okay, I got a 1, so he's number 1, which is appropriate for Ricky Bobby. So how do we say that? We want to filter by customer ID of 1. Customer ID equal 1? Not really. It's not really called customer ID on the customer table, is it?
No, it's
You could say O dot customer ID. That'll work. That will work, and so would this. Usually you'd use the primary key. Either way will work.
What happened to the sum?
We haven't done it yet.
would you change the select statement too, since
Yeah,
we're
but
not
that's
getting
easily
a
done,
first and
but
last
this
name
first
anymore?
part was.
Or since I don't really care about that.
So Anna's saying she doesn't really care about the first and last name. Can we just get rid of it? It's like, okay. It's going to be hard for anybody but a database administrator to understand what this means. But yeah, it's just for you. You're doing it for your own purposes. You just want to see the ID. Okay, there you go. Now let's put that back in just for the humans among us. So we got customer ID of 1, full name is Ricky Bobby. Now those are all the extended prices from all the line items. So now you wanted to know, give me the sum total. How do we get rid of all these duplicates? What looks like duplicates, and it's like, give me the sum total.
You group by after where? You group by the extended price. So,
Let's try that. Let's try extended price. The rule here is you want to group by, anything you list in the group by, it's going to look at the distinct values in that list, and it's going to give you the distinct values. Is that what you want to do for the, let's see what this gives us. Let's see what this gives us. So I'm going to group by that. The select statement projection, the fields you have in your select statement are related to your group by. Anything you list in your select statement has to be referenced or addressed somehow in your group by or with an aggregate function.
Is it in the select statement or is it in the group by? It has to be in the select.
Let me help you out here. Let's do this wrong to begin with. So let's try that. It's wrong because, not that because you're writing it technically wrong, but because it's not going to give you the answer you want. Why is that not giving us the answer we want? Somebody in Richmond, help us out here.
They can't see it anymore, can they?
Well, if I switch over there, yeah, they can't see it. But here, what's going on here? Somebody in Winston-Salem. What's going on here? Why didn't it give us what we're looking for? Because we're saying group by that. Anything you put in your group by, it says, give me the distinct values. In actuality, you don't want the distinct values of extended price. You want to sum that. So it's kind of reverse thinking. You leave that out of your group by and you group by everything else. And you want to sum. This is where you have to say sum up here. Okay? So you give me the distinct values of this one and then sum that one.
What if you want can you do like a list, like group by, where it lists all the things he's purchased and then another column that has a total too?
So Anna is changing the specs on us. She's saying, now I want to see all of the things that he bought and another total by. You got to think through logically what you want. So you've got Ricky Bobby, and he might have bought, I don't want to speculate about what he likes to buy, but say he bought 2 products. You want to see a total of what's the total by product. Whenever you do a group by, it's going to give you the distinct values of each of the columns you specify in the group by. So in this case, we're going to have the customer name. What's the other thing that you want to group by? What other thing do you want to see in your report is another way to put it. Do you want to see the name of the product or the order number? Like maybe we group it by order number because we have that. How would we do that? Somebody help her out. How do we group so it's not just the total he spent, but it's the total for each of his orders?
So you need the order information?
We need order information, but we have it. We've joined it. So it's all there just laying there waiting for us to do something with. We want to group by order information too. So the order header. So how do we say the order ID? Okay. And if you group by it, it's usually the case that you should show it too. So we got Ricky Bobby there. And now how many rows are we going to have? We're not going to have just one anymore. And it says order line.id it's not order line ID, it's order ID. My bad. We're going to have 3 because he had 3 orders. And what it's doing, it's saying, give me the distinct values of name in customer, give me the distinct values of order. So it's going to create a row for each one of those distinct values. And then look at what it's doing for extended price. You have 3 line items or 2 line items for each one of these orders. Don't show me those line items. I want you to run the sum on the fields in that. And just show me the sum in that context.
So it's the sum of each individual purchase?
It's for that order. Let's go back and look at, so we've got, the reason we created this little database is you can look at all of the data in the whole database at a glance. So let's go look at order 1, 7, and 8. So order 1, let's go look over here and see what order 1 is comprised of. Now, for users, this would scare them. But for developers like yourselves, it's like, no, I kind of understand what's going on. That's an order ID, quantity, and price. Order ID, quantity, and price. That's row 1, row 2. So there are only 2 rows that relate to order ID of 1. That's it right there. So I've got a quantity of 3 for $2.50, so that's $7.50. And I've got a quantity of 1 for $17. So $7.50 plus 17. Let's see if that's right. Easier than looking at the DDL. Give me a little diagnostic query to check my results. How do we say, show me all of Ricky Bobby's details. Show me all of his order lines. We have that up here, don't we? Yeah, we have all the order lines up here. Let me run this again. Let's look at order ID of 1. Okay, there it is. So the first query is the detail because we didn't group it. The second query says it's exactly the same joins. All we want to do is group that last bit by order ID. So collapse the duplicates in that column or that group of columns and run an aggregate function on this. Now if I want to know how many line items, once you've done the hard part of structuring the query, it's really easy to start using other aggregate functions. So I want to say, show me how many order lines he has. Once you've done the grouping, it can aggregate anything you want. If you want to say, you know, what's the maximum he spent on any one line item? Within that order.
This is so helpful.
Make more sense?
It's starting to like, yeah.
Okay, so this is why you use aggregate functions. If you want to know, if you're a statistician, you want to know what's the standard deviation of his spend on line item. Within each order, so it's not going to be much of a variance. There it is. Complex statistical calculations done for you with one line of code. The hard part is understanding what this group by is doing. If I did this, I'm going to break the world. Because it doesn't make sense. This will work. It's like, what does that mean? We've grouped too much. We're saying, give me the distinct values not only in name, not only in order ID, but oh, I care about that being distinct too. The problem is, that's going to give us one row. We've made it, you know, we've grouped down to a single row, which completely defeats the purpose. So that's the way to think about grouping. Anything you put in your group by, you're saying, give me the distinct combination of those columns. And then, why do you do that? Usually you do it one of two reasons. One is because you want to do it distinct. Okay, you don't have to use an aggregate function. Just make it distinct for those columns. Exactly the same thing. Another reason, this is more common, because you want to have the benefit of using an aggregate function, sum, count, max, min, stdev. There's only like 5 or 6 of them, and we've got most of them here. I want to run that on one of the columns not grouped by. In this case, extended price. Another common would be a date, like give me the latest date or the earliest date within this context. So you group by everything except I'm going to run an aggregate function, max or min, for latest or earliest of that date. And that's going to give you, oh, what's the earliest they did whatever. I want to leave you with this idea. We're going to take a break. I know it's been a long spiel here. As much as I would like to, I can't matrix style stick something in your brain that says, you know SQL now. I wish I could. I'm trying my best to impart this information, but you realize by now, no matter how many times I go over this, you're going to have to go try and practice and make your own mistakes. And I'm going to be here for you when you have those barriers. but you've got to go put in the time. Remember back 2 weeks ago where you didn't even know how to code anything, and now you got like 3 or 4 languages at least, probably 5 or 6. Think about how far you come. You're only going to stick with it and succeed if you put in the extra time and recognize for yourself. Don't treat this like I'm going to high school and I'm going to sit here and kind of space out a little bit. Because if you do that, we're going to finish the course, I'm going to shake your hand, and you're not going to have the benefit that you signed up for. The only way you're going to get it is if you challenge yourself. And I can't do that for you. My job here, instead of making our customers happy for these 8 weeks, in my mind, it's I'm going to lay on every little bit of information I know from the past 20 years on you. I can't make you pick it up. Let's take a break.